Swayam Prabha. Digital India. Educated India.
Hello, my name is Harsh.
And my name is Sanvi.
We are both from 9th grade representing Scottish High International School.
And we're here trying to wrap our finger around the confusing laws of thermodynamics.
Thermodynamics? What is that?
I can't seem to recall hers. Do you have any idea what it is?
I'm quite sure that it is a branch of science, more specifically physics, which talks about how energy and heat transfer through matter and objects in the universe.
There were 4 laws, right?
Yeah.
I think I remember the
so.
zeroth one.
Zeroth?
Yeah, I think it talks about how if object A is in equilibrium with object B and object B is in equilibrium with object C, then object A and C are in equilibrium with each other.
Oh.
Do you remember our teacher showed us this experiment where she kept 2 glasses of water, one hot and one cold,
Right.
and after some hours they were in equilibrium?
Yeah.
In simpler words, I would put it as if x is equal to y and y is equal to z, then x is equal to z.
Oh, that makes a lot of sense when you put it that way.
I know. Harsh, do you remember the first law?
First law, it has something to do with that energy cannot be created or destroyed. It can only be transferred. Wait, let me show you. So, if I have these 2 balls, then if I hit this ball with the other ball, then both of the second ball goes slightly forward and this ball bounces back slightly. This is because this ball transferred its kinetic energy to the other ball, causing it to move forward, and this ball got its energy transferred back to it, causing it to bounce slightly backward. Let me show you that again. Look. I throw the ball, and this one goes forward, and this one also bounces back slightly backward. Isn't that cool?
I know, it is. Harsh, do you remember the second law?
Second, entropy? Entropy, something.
Do you know what it is?
No, I'm not really sure. What is that?
Entropy basically talks about the randomness of objects. So, for example, here we have 2 liquids, and while mixing them, the randomness increases. This is what this law talks about. The law states that entropy always increases. For example, you have an ice cube. An ice cube will melt as it absorbs the heat from the surface and the atmosphere, and the particles gain more randomness. Hence, the entropy increases. Isn't the third law also related to this?
I think it has something to do with entropy more.
Do I do this again?
Yeah, do this again and then repeat that one and let the ice cube be there on the tray because till then it will melt.
Okay. Entropy talks about the randomness of objects. For example, mixing 2 liquids or mixing milk and coffee. As you can see, the randomness of particles only increases. It never decreases over time. For example, an ice cube, it absorbs heat from the surroundings and the randomness of the particles increase, causing it to melt. Harsh, do you know anything about the third law?
I think it has something to do with entropy as well, but it's relation to temperature, I think.
Ooh, it talked about how if a perfect crystal reaches to absolute 0, the entropy reaches a constant, I think a 0 constant, as the particles stop moving completely and randomness stops.
Right, I think we did this in physics class.
We did. Hey, Harsh, remember the rap we had?
Yeah, I do. Yo, let's talk about thermodynamics. Laws so profound. In the heat of the moment, let the knowledge surround. First law, conservation, energy can't disappear. It transforms and evolves, make it crystal clear. From heat to work and work to heat, it's a cycle, a dance, can't cheat the beat. Internal energy, a hidden force. In a system's heart, it's the driving source. Laws of thermodynamics, breaking it down. First law's conservation, seconds all around. Entropy is increasing, disorder is the sound. In this energy game, we're playing by the profound. Second law, pay attention, take heed. Entropy is the player. It increases with speed. In an isolated system, chaos takes hold. From order to disorder, watch the story unfold. From hot to cold, it's a natural flow. In this energy game, we reap what we sow. No perpetual motion can break the chain. Entropy is rising, it's the name of the game.
Laws of thermodynamics, breaking it down. First law is conservation, second's all around. Entropy is increasing, disorder is the sound. In the energy game we're playing by the profound. Third law, stepping in. Absolute zero is the goal. As temperature drops, entropy takes a stroll. Perfect crystals at the lowest of lows. In the quantum realm, the mysteries unfold. Absolute zero is hard to beat. No movement, no heat, it's chilling feet. The third law, a chilling on core. World of thermodynamics, you gotta open up the doors. Thank you.
Thank you.